All right, good morning, good day. Hello and welcome. This webinar is uh, about the AWS Certified Developer Associate exam. I'm here to talk today about domains 4 and 5, as well as a little bit about the exam itself. My name is Stephen Cole. I am the AWS Certification Specialist at Cloud Academy. My contact information is on the screen, and you can reach out to me or connect with me in multiple ways. Today, I'd like to talk a little bit about myself and my experience with the exam. I want to talk a little bit about the exam itself, just to kind of an overview of what it takes or what the exam is like. A little bit about the experience of taking the exam in the privacy of your own home. Then I would like to talk about domains 4 and 5. Domain 4 is refactoring, and domain 5 is monitoring and troubleshooting. So this is me. I currently have 8 current AWS certifications, including the developer cert. I'd let it expire, and then a couple of weeks back, I took it again just so that I would have the content fresh in my mind, in my head. And if you wanted to see these badges for yourself, there's um, there's a link at the bottom of the screen that you could follow. If you were to click on one of those links, it would explain to you or describe in detail or in some detail of what the exam really is about. And it says that the earners of this certification have a comprehensive understanding of application lifecycle management. And I put this up because I want everybody to understand that the developer certification, the developer associate certification, is not really about just coding and programming. It's really more about the support, the care and feeding, if you will, of developers in the AWS cloud. It's less about understanding, well, how do I do this thing in Java, and how do I do this thing in Python, or how do I do this thing in Golang, or how do I do this thing in whatever language it is, and much more about creating an environment that is suitable or hospitable to being a developer in the cloud and understanding what it means to write applications that are cloud native or cloud friendly. So once you pass the exam, you get a electronic certification. I've got a bunch of them. I keep telling myself that I'm going to print them out and put them on my wall. And you can see that the issue date was March 12th of 2021, and it is good for 3 years. And if you already have the cloud practitioner exam, it will automatically renew that cert. After you pass, it'll tell you that you passed the exam if you've never taken an AWS exam before, but it won't give you your score, and it won't give you anything officially right away. Like as soon as you take it, it says you passed, then you kind of relax and say hooray. But the next day, you get an email. Sometimes it's 2 days, but it's usually within 24 hours. You get an email that says, here's what your exam results were, and here are your strengths and weaknesses, what you need to work on, and what your score was. And I'll talk about the overall score in just a minute, but it's a scaled score that can be as low as 100 or as high as 1,000. And here you can see that I have a score of 905, and I passed. Then it'll break down each of the domains, and there are 5, and what the percentage of the exam lays out being, and it'll tell you if it needs improvement or if you have achieved basically the competencies around it. Now, it is possible to pass the exam and fall into that needs improvement. It doesn't have to be perfect for all of the domains. This is true of all of the exams. I have taken exams and passed them and had markers in the needs improvement space. So I do know for a fact that you don't have to get a perfect score in all domains to pass. The exam itself is 65 questions. It's multiple choice and multiple response. I'm asked questions about the multiple response. Do you get partial credit? And the answer is no. The question is either right or it's wrong. And the multiple responses will always have 5 or more options to choose from. So if it's choose 2 or choose 3, you will have to choose those out of 5 or more different options that are available. You have 130 minutes to take the exam. And if you do the math, that's about 2 minutes per question. Now, what my experience is that even though that's true, there are a bunch of questions that are like they're real short. They're almost gimme questions. Like if you've done any work in the cloud at all, any kind of developer work or architecting work, if you do any work there, that you can recognize right away that this is an easy answer and there it is and boom, and you go. But you can flag questions and you can come back to them. You can and mark them for later review. So if you're not sure about something, then you can come back to it. So, but you have about 2 minutes. Most of the questions at the associate level are about a paragraph long. Sometimes they're only a sentence long, but they're a paragraph long, fairly simple, and they ask you a question about that, whatever was presented, and give you 4 possible answers. And those answers, we're going to come. There's some tricks to understanding those, and we'll talk about those a little bit for the multiple choice anyway, and then the multiple response is 5 or more. A passing score is a scaled score of 720. You have to have at least 720, so 70%-ish or 72%-ish out of 1,000. And what makes this interesting is that it's a scaled score, which means that you don't ever get your raw score. You never know how many you got right or wrong. Each question is weighted, has a weight to it, and AWS determines, the certification people have determined what the weight is for that question. That's part of the domain, it's part of the exam itself, and there are usually, it doesn't tell you which ones they are, there are usually some exam questions that they're testing out. They're not sure if they're going to make it to the final exam, if they're really good enough, and they'll pepper those in. They'll be a little bit different, and they don't count. So even if you get them wrong, or if you get them right, they don't impact your overall score, which is why you have a scaled score that is sent to you a day later. If you take the exam at home, which most places are, at least that I'm aware of, there's some things that you have to be aware of. You're going to have the day of the exam, you're going to have to log into like I use Pearson VUE. You're going to have to log into Pearson VUE, and they're going to say, oh, you need to take a picture of your ID or IDs. I use my passport. And then they're going to ask you to take pictures of the environment that you're in. So you have to take 4. There's one of, I think one of them is of yourself. So I guess there's 5. So, because they'll compare your picture that you take of yourself to the ID that you have submitted, but then you take a picture of your environment. So from looking at your desktop or your computer, a picture of your desktop from the left looking right, from the right looking left, and from the front looking at the back. The idea is that they want to make sure that there's nothing around you that could give you any hints. They also want to make sure there's nobody in the room or around you, and they want to make sure that there's no way that you could share the exam with anybody else. It's supposed to be private. So no technology within arm's reach. I remember my first time that I took a proctored exam. They basically take your laptop and turn it all the way around so that they can see things and they can see my desktop. And I had a pair of earbuds that were on the desk next to my computer, and they're like, oh, those can't be there. So they weren't plugged in. I wasn't using them, so I had to wrap them up and put them someplace else. And I had to what else? I had to make sure. I think there was no food or drink during the exam, so you can't have a bottle of water or a snack or anything. So go in hydrated. Go in with whatever food you need, because you don't get a break, right? There's no break. You can't just say, excuse me, can I have a timeout? Can I have a pause? I need to go pee or whatever. You have to sit still, and then no voices can be heard. Now, when I took, I literally mean no voices can be heard. You will be questioned. The proctors watch you the entire time, and we're going to come back to that in a little bit. And the proctoring, you're going to be watched, and they're going to listen to you. And if they hear voices, they have the right to shut the exam down with no refund, no score, just not even a thank you for playing. You have to agree to 4 major clauses when it comes to taking the exam at home. And what the first thing that you have to agree to is that you acknowledge and agree to the video and audio recording of your entire testing session. So they're not only watching you, they're recording you. So if they think that you're cheating or doing something to promote cheating, they can shut it down. So you have to agree to that. Then you have to admit, or you have to acknowledge rather, that it is okay that you and your computer will be monitored during the entire testing session in real time, so that your face, voice, desk, and workspace will be captured for the purposes of test quality, security, integrity of the exam. So you are being monitored, and this would be true if you went someplace else too, right? If you went to a testing center, they still have cameras, but they're telling you that you're going to be monitored in the privacy of your own home. Then it says if a third party, and this is not a puppy or a cat, this is a person. If a third party is detected as being present, whether visible or not, overheard in any manner, or physically detected through movement or making noise or sounds, they can terminate the test and you will not receive a score. And you will not receive a refund, you will not get a credit, you will not get a voucher. It's just over. So you need to make sure that you are in a space that is quiet, that is isolated, and separate from the rest of the world. Then there's this statement that says Pearson VUE may use facial comparison technology for the purpose of verifying your identity during the testing process. Basically, it's using the computer, not just the person that says, oh yeah, that's the same, because we don't always match our IDs. So they actually are in Pearson VUE in this case can actually use facial recognition technology to compare the photos that you take, the image that is of you on the webcam, and the ID that you have shared. So let's get to the exam. Let's talk about the exam. So there are 5 domains: deployment, security, development with AWS services, refactoring, and then monitoring and troubleshooting. And refactoring, monitoring, troubleshooting are what I'm here to talk about today. And the nice thing about this is that the domain is, I'd say it's got a fairly even distribution. I mean, some exams are really weighted to 1 or 2, and while it's fairly even, domains 4 and 5 are a little on the light side. But before we get into that, I do want to talk about the exam questions. And this is probably even more relevant to the professional level exams, and to an extent the specialty exams. But really pay attention to what's being asked. There's a little paragraph at the beginning that describes the question, and I've got a couple samples that I've created of what a question wording might look like. But then there's usually a clarifying question at the very end of it. And it's really kind of easy to think, oh, they're asking me for something. They're asking me for what service, or they're asking me for how do I make this secure, or how do I make it better? And sometimes they're not. Sometimes they're explicitly asking, how do I do this cost efficiently? How do I do it just efficiently? Oh, I wrote cost efficient twice. It should be just efficient versus cost efficient. So the goal here is, or the idea is, that pay attention to what's being asked of you, because the most efficient might not be the most cost efficient, or the most secure, or the most performant. Sometimes you have to make a sacrifice for the answer that's related. So maybe you just want to, how to optimize performance. What's the best way to do the thing? And it's the best way of what's being promoted, or as part as the answer goes. So if you think about it, sometimes, and I'm going to say this probably again, or more than once, because it's important to remember, is that you're going to be given 4 possible solutions. And some of them are going to be wrong, blatantly wrong. And there might be one or two that are correct, but they're not the way that you would do it. So you would have to choose the best option, the best solution that they've given you that's available. And it sometimes can feel a little weird. So again, the correct answer might not be a good answer. It might not be the best practices answer, but it's the best one available. Um, Often taking the exam, there are really quickly two answers that are just like, they're wrong. If you've done any work inside AWS, like any real work, and made anything in this particular domain, whatever it is, you're like, that's not even a thing. And you could just say, that's out. And sometimes it's easy to eliminate two of those like really bizarre off the wall answers. Get rid of two, then you have a 50-50 shot. But if you read them carefully, there's usually wording in there that can give away which one is the correct answer. And then again, avoid adding your own bias to the question and answer. So it's not really, well, this is how I would do it. Well, like, you need to refactor an application from an on-premises thing, and you may be thinking how you've done it in the past. Well, how that may not be how it's being actually presented in the exam itself. So pay attention to how you feel about the question and what you're thinking about the question, and then put yourself aside. Make sure that to put the ego over to the left, and see what the best answer is that's available to you. So with that said, let's get into domain 4, refactoring. So it's 10% of the total exam, and 10% of 65 is going to fall in between 6 and 7 questions. And there are 2 subdomains, and you want to optimize 4.1, optimize applications to best use AWS services and features, and then migrate existing application code to run on AWS. So really what this comes back down to is, what are we going to do to move an application into the cloud? Not necessarily building from scratch, like not a fresh build, but what do we have to do to change, modify the code we have so that it works into the cloud? And the fundamental thing behind this is really to think about things as services, not servers. Virtualization, right? So making a virtualized environment, whether it be a virtual computing instance with an EC2 instance or something with containers, it's really easy just to, hey, I'm going to virtualize this and throw it in the cloud, and you're done. But the trouble is with servers, putting them up there, is that they're going to run all the time. And that is against kind of a best practice in the cloud. In the cloud, when you're running, you really, if you're not using it, you want to turn it off, because you pay via consumption. You pay for what you're using. So if you're not using it, you should turn it off. You should remember to turn it off. So if you design a service that can be turned off when not being used, scaled up and scaled down as appropriate, then you're going to be in a better position to pass the exam and to be a better practitioner of, or a user of, Amazon Web Services. So for example, a simple application on a single server. So a lot of times your servers are going to run at 10% utilization anyway. So that's 90% of that bill that is being wasted. Now, lifting and shifting, the idea of putting something in the cloud right away, just saying, hey, I need to get it up there. I need to get it off my on-premises server. I'm gonna take this virtualized instance and I'm gonna just move it up to the cloud. Great. That is a fine way to get started, but that's not where it stops, right? You have to keep going. So if you have a simple application that does one thing really well, then this is a great use case for a Lambda function. So it's basically optimizing the application, refactoring, rebuilding, recreating. And if you just have a little function that all it does is normalize data, all it does is alphabetize things, all it does is insert something into a database, all it does is one thing really well, then ditch the server and make it into a Lambda function. Likewise, hard-coded message delivery, any kind of connection that requires always on. I've had more than one application be directly connected to a database backend, and that connection has to be there 100% of the time, because when it's not there, either the application loses its mind, virtual mind, I guess, or the database does, and it's just got to be there. So instead of that, then the refactoring that should happen is putting something into an SQS queue and using fan out with SNS. So the simple notification and the simple queue service are ways to take, rather than having a direct connection that's always on that requires that database to always be there, then you put something, you take the output of your application, you put it into a queue and let it get picked up when it's appropriate. Another thing, storing assets on, or digital assets on servers. So we build web services, right? That's Amazon Web Services. We're making a web application. Well, why would we want our stuff on our EC2 instances? Well, because, you know, early in the days of, or at my education inside AWS, they talked about don't think of don't get attached to your resources. Don't think of them as children or pets, right? You don't want to think, because they're going to go away. You want them to be ephemeral. You want them to be able to be spun up and removed when you're not using, or spun up when you need them, removed when you no longer need them. So rather than spend a ton of time trying to like spin up a new EC2 instance, it's a web server, and copy all the data on there so that it works, just put those digital assets in something like Amazon S3 so that you can point to them when you need them. And that could be something as for like a web server, but it could also be configuration files for your web server, or it could also be configuration files for some other process. Rather than save things on your servers I should be able to kill in a moment's notice because of whatever reason. I mean, RESTful applications, we're talking about representational state transfer. REST applications don't store the state of the application. They don't care what happened before, and they don't care what comes after. You just need to be able to get the data. So being aware of that is going to be vitally important to being successful in AWS and on the exam. Another kind of bad idea, worst practice, custom authentication systems. Now, it's sometimes can be fun if you have that kind of mentality, and I will say that I do not. But there are some people that are like, oh, I could build this, and I could, because they want total control. They want, these people just have to have absolute control. They want to know what everything is happening, and they want to manage it. Well, that's a lot of work, and it takes a lot of effort, and it takes away from maybe the business at hand. So instead of doing some custom identification or IDP identification providing system and reinventing what's already available, use a managed service like Amazon Cognito or AWS Single Sign-On or the Active Directory connector, or there's lots of ways to do it. The idea is that there are tools to use, and some are more expensive than others, and some don't have cost at all. That's part of the cost of doing business. But be aware of what else is available so that you can leverage the existing services. Because if you leverage existing services, then when it comes to monitoring troubleshooting, I have a better and easier path to figuring out what's going wrong. So it's not just a matter of, oh, here, buy this service from us, but it's integrated into the overall architecture and the overall ecosystem that lets me troubleshoot later on. Custom session state solutions is another one of those kind of bad ideas. Like, oh, I'm going to build this myself. I'm going to have total control. I love control. I'm just got it. Well, it takes effort and it becomes brittle. And brittle is the one thing that is kind of the enemy of cloud computing, because we really need to design our systems to be flexible. We need to design our systems to handle. I mean, we talked about high availability and fault tolerance. But if it's super brittle, if there's a little bit of a slip, a little bit of a breakage, I need the system to keep running because I don't really want to have to keep fixing things by hand over and over and over and over again. So instead of using custom state solutions where you're creating a login and you get this EC2 instance and you got to get there, but you got to manage use some sort of caching solution like with Elasticache, specifically Redis, not Memcached. And if those words are new to you, you should probably take a look at them before you take the exam. Amazon Dynamodb is another way to save state. It's a very popular way, a key value store. that lets you kind of do some lookups and save the state of a transaction so that you can manage it without having to build it yourself. And again, it has hooks into other things as we talk about monitoring and troubleshooting. Then there are, I was not sure about putting this slide in my presentation for today, but I thought, well, you know what, we should talk about these things briefly. The lift and shift, the idea of putting something into the AWS cloud. Sometimes just getting it up there means creating a virtual machine of some kind, and then just running with it. And that would be EC2, or if you're into containers, either the Elastic Container Service, ECS, or the Elastic Kubernetes Service, EKS, which is just a nice way to get it up there. But like ECS and EKS with containers, that's more about orchestration. There are not a ton of orchestration questions on the exam. And by not a ton, I mean, I can't think of any. If there were some containerization questions, they weren't about like, what do you do? How do you do this thing? It was much more of, well, how do you get the data to and from it? And it's really an awareness of that you don't have the ability. If you use containers, you can't save any data in the container itself, which means that you really need to know S3. Right? You really need to know how to save data externally to wherever you want to send it, whether it be S3 or RDS, which I put it on this slide as well, without using there's no like local storage on the container itself. So these are the things you have to be aware of. Do you need to know containers inside and out to pass the exam? No. Again, I can't think of any real questions about containerization and containers, even virtualization. But they do have questions about how do you look at the logs? How do you get the information out, and which we'll talk about in troubleshooting? How do you manage the breakage, the failures, or understand what's happening with your application? And if it's just kind of encapsulated inside some sort of virtualized machine, you're going to be limited. So common services that you should prepare and study before taking the exam. Again, kind of out of order as far as importance. I mean, S3 probably would be the #1 thing that I would say you really need to know and understand how I can effectively and efficiently use Amazon S3. I mean, it's just a thing that is important. Elasticache and Dynamodb, I did see some questions that referred to them, not necessarily the infrastructure. Those kinds of questions show up on the architecting exam and the SysOps exam. This is much more about the appropriate use of these services to effectively create a path to moving data through AWS. API Gateway, there were a number of questions about API Gateway. And really it's an understanding of, well, how do I manage multiple versions of an application, or in this case, multiple versions of an API. So, and we'll talk a little bit about that in a few slides, but you really need to know that service in terms of the of how you manage deployments. Sqs and Sns are vitally important. More Sqs, less SNS. The simple notification service is an alerting type of a system, letting you know something's happening, letting another service know that there's something happening, and you should know it, but you really should understand SQS. SQS, for a little bit of trivia, before there was Amazon Web Services, it was the Amazon Web Service, and that web service, that single service, was SQS. It is the oldest service that AWS has available, and there's a reason for that. It's the thing that they needed to separate those always-on connections. Other things that you should be aware of before you step into the exam, at least, I won't say at a high level, because you do need to know some depth to a couple of these. IAM, the Identity and Access Management Service, and it's really about how do you manage access, right? That's a security question. But at the same time, when you, from a refactoring perspective, when you have to manage like the secure access to a service, you really need to understand how roles work and how permissions work. Not necessarily like, how do I give this specific permission to this specific object? It's much more of, oh, this isn't working. I need to be, because I need to give permission to it. And here's how I give permission. And I don't, and it's kind of, it's almost cliche for me to think about, but the idea of embedding credentials in code is probably the closest thing to an RBE that you're going to get. An RBE is a resume building event. So please, if you have to put your application or your credentials in your code, ask for help, because we're going to have some sort of intervention. Cognito, again, this is really just about kind of like, how do I manage the authentication mechanisms? You should know what an identity pool is. You should know what a user pool is. You should know how a little bit about identity providers, a little bit about SAML, just not necessarily to how do you configure them, but when would you use them and why are they important? I mean, there are some people that just want to manage their own authentication services. And sometimes I just need to authenticate. So I want to use a different provider. I want to use somebody else for them to authenticate, and then I can give authorization once it's approved. So how do I do that? Step functions in KMS. Step functions. So inside microservices solutions with, especially working with something like Lambda, if I need to have multiple steps to create a single transaction, then, and they all have to succeed or they all fail. Like if one of them fails, the entire thing fails. The way to build that is with a step function, and that's a thing that's becoming more and more. I won't say common, but I would say it's more and more prevalent. I've seen more and more of it, especially on the exam, to understand that I can create a bunch of Lambda functions or workflows that all have to succeed for the entire thing to move forward. So know and understand step functions, and then at a basic level, how KMS works. Now, again, from an architecting point of view, you'll see more of that on the SysOps exam and the architecting exam. Here, you need to know, oh, I can use KMS to secure resources, to encrypt things that are at rest before I send them someplace, or however I want to manage it. You don't necessarily need to know how key rotation works, and you don't necessarily need to know how like symmetrical versus asymmetrical encryption works. It's much more of, well, how do I encrypt this, and where do I put it in the chain? Like, where do I need to encrypt it and decrypt it every time I move it around, or not? So what does the exam look like? What does that? How do I feel about that? So here, I can't give you the questions, right? I have to, when I take the exam and I say I want to take the exam, I have to agree that I will keep the exam itself confidential. And I will. So I'm not going to give you an exam question, but I'm going to give you, because I don't have access to them, but I'll give you my idea of what it would feel like from an exam perspective. So here you are using Amazon API Gateway to manage access to AWS Lambda Functions. Right? So I'm not just calling the function, I'm using API Gateway. So I have an API, a custom API Gateway that I'm using with the got the API. I'm using with API Gateway to call the Lambda functions. I need to make a change that, when implemented, will break a couple of my existing APIs. Not all of them, some of them. I'm going to break something. So how do you minimize the impact on existing users and give them time to migrate to the new version of the API? And again, this is a refactoring thing internally. So this is, I've already got it up there, but now I need to make some changes. And this kind of alludes or carries itself towards the idea of, excuse me, of how do I manage multiple versions of a thing? And there's a lot of different ways to approach this question. But the idea is here, how do I minimize the impact? Which means that I need to figure out a way to manage how code moves through AWS. Now, if you have only been exposed to EC2 instances if you've only been exposed to like virtual compute that way, then you're going to be thinking, oh, I need a load balancer. I need to use an application load balancer, and I need to have different targets. And you'd be on the right path, but you'd be in the wrong forest, because with APIs, what you're going to need in this case with API Gateway is stages, and you need to know about stages and staging, and the idea that you can create multiple stages for an API, and I can say, oh, you're going to use this version and you're going to use that version, and I can use API Gateway to manage the how it moves through API Gateway. Now, if you look at this, this is actually a part of the documentation that I grabbed, did a quick screen capture. It's a named reference for a deployment. So I can have multiple named references for my deployments, and they can be optimized, and I can enable caching and throttling and logging. And these are the things. You don't necessarily have to go into all the detail. You need to know what they do, or what a stage is, how it can help you, and when would I use it. Another type of question, and usually, like in the exam, you'd see something like your company or your organization, or you work for a company, or an AWS developer is doing this. And rather than try to figure all that out, I'm just saying you are migrating your on-premises monolithic-based application to a microservices-based architecture. You need to refactor your application so that the microservices can communicate asynchronously without impact to performance. What AWS service or services can do this? Now, in a question like this, it would probably be, what services can do this? Name 2 or name 3. I didn't want to go into all that kind of detail, but this is just to really check your understanding of what's available to you, excuse me, as a as somebody that works inside AWS. So when I look at, actually, before I go to that, there's the answer. But when I look at these things, I'm looking for the keywords communicate asynchronously, and that is SQS. That is, I want to put something into a queue, and I'll get it out later. And if I lose the application that's sending the data, the queue information is still there, and how to manage that effectively. SNS to an extent as well, because I can subscribe SNS to an SQS queue, and then I can use that to send information in various places. And looking at something called fan out is going to be something that you would want to do to prepare for the exam. Also, as part of SQS, you're going to really want to know what long polling is and short polling is. I have taken the developer exam twice. I took it back in 2017, and then because of COVID, let it expire, and then took it again just this past couple of weeks back, past March, or whatever day is. I don't even know what today is anymore. But took it back in March, and I've seen both times. I remember references to long polling and short polling, so you need to know what they are. And I'm going to come back to that a little bit later. So you are using Amazon Cloudwatch to monitor Amazon SQS metrics. Your SQS consumers, are polling a queue as fast as possible to ensure high throughput. This is wasting CPU cycles, and because responses are empty, costs are increasing. What can be done to reduce the number of empty responses? This is one of those questions that is trying to ask you, how do I make this better by limiting the amount of stuff that's coming back, right? I'm making requests is super performant, and maybe you'll see something that's the opposite of this, or how do I have something that's not performant and make it performant? And they're going to be related. But here I'm trying to figure out a way to reduce waste, and I'm trying to be more efficient. And I want it doesn't talk about cost, but that's probably going to be related in some way. And this comes back to that whole long poll, short poll thing. So what you're going to want to do is look for an answer that has long polling involved. And long polling, it says here in the documentation, reduce empty responses by allowing SQS to wait until a message is available, right, in the queue. You want to make sure that it is ready and to get something or to receive something. And this whole receive message action is really, really important to understand. And specifically, I'm going to tell you that if you're not sure about this, you should look it up. And specifically, receive message wait time seconds is vitally important to understand. There's very few technical questions on this exam. Very few times are they going to say this specific thing. It might be a couple IAM policies that show up that just ask you to know if what's happening. Is this an accept? Again, this more of the security question, allow or deny. But this is one that I've seen multiple times in other exams as well. Receive message wait time is critical to understand. And it's part of set queue attributes. And spoiler alert, it's the length of time in seconds that receive message waits, or the action waits for a message to arrive. And inside the documentation, it tells you what the valid values are. It's a range, and what the default is. And I'm not going to tell you what they are. I have blocked them out on purpose because you need to go look them up. If you want to pass this exam, okay, maybe that's hyperbola, but if you want a little bit of an edge on the exam, you'll need to know what the valid values are for receive message wait time seconds and what the default is, because sometimes there are questions that could try to trick you in the sense that it assumes that you think if you don't know what the default is, you need to know you need to know what that means and what to change it to and what the maximum could be. So my gift to you is a little bit of effort, and I'm sorry for making you work, but this is something that by looking it up and understanding it will help you in the long run. Another question: you have built a distributed application with microservices using AWS Lambda that has replaced an existing monolithic application. So again, we've already refactored it, moved it over. Then you have, in effect, created a state machine using Lambda functions. The problem is that the legacy code that interacts with the machine is brittle, or the state machine is brittle and breaks often. What service, AWS service or services, can be used to manage the state machine instead of the legacy code? So we're trying to get you into a cloud native mindset. We're trying to move you forward in getting away from these things that are brittle, that require manual intervention. A long time ago, I learned that if you have to log into a production instance or a production system, your automation is broken. And that is a truth. You never want to have to fix anything directly in a production service or system. You want to fix it in development, and you want to migrate that code up. You want to have a pipeline that moves it into the right place. And so this is one of those things that addresses that. So what are we going to do when we talk about Lambda functions and state machines? And I can guarantee you, because I wrote this, that we're going to be looking at something involving step functions. And a step function, this is a tool. It's an orchestrator. Orchestration seems to be one of those kind of new buzzwords. We have container orchestrators and container orchestration, step function orchestration, what was the thing there was a thing with code pipeline, code orchestration, or there's another probably better word for it. But the idea is here, we're looking at a serverless function orchestration that can manage these Lambda functions for us in a much more resilient way. We brittle things break. I don't want to have to be on call. I want to be notified that I want the system to fix itself, and I want to be notified that a fix happened. And because of the way that step functions work, you can put checkpoints in there, and I can keep track of things, and I can let all systems pass or all systems fail. And the output of one step acts as the input for the next. So I can have a sequence of events, because Lambda functions they run when you call them. They're asynchronous. You say, I want you to run, and it runs. But if I need the output of one to be the input of another by itself, unless I call the function from a function, I'm just going to string them through. And if I do that, I have have an interesting problem because what happens if it breaks? This addresses that. All right, so moving to domain 5, because I have 15 minutes left in what I want to be in my presentation, because I want to be respectful of everybody's time. Monitoring troubleshooting. Monitoring and troubleshooting is, I think, it can be complicated, it can be complex. It's not difficult, and there's not a lot of it. It's 12% of the exam, it's 7 or 8 questions. But the nice thing about it is there's not a ton of tools that are widespread that do monitoring and troubleshooting. And unlike, say, something like refactoring, where, oh, I've got to kind of rebuild my architecture so that I can make this thing resilient and distributed, here I'm looking at ways to track the things that are happening inside my environment. So the specific things, the 2 subdomains, are to write code that can be monitored and then perform root cause analysis on faults found in testing or in production. So writing code that can be monitored, and that kind of takes us back to the very beginning of this webinar when I was talking about, oh, you're going to be watched. So watching, I don't speak Latin, but quis custodiet ipsos custodes, who watches the watchers? And that should be you. But before it's you, that should be something inside AWS that can watch on your behalf. And those services are going to be either, we're going to come to it in just a minute, Cloudtrail and Cloudwatch. And if you think about monitoring, there are 2 types. There's proactive monitoring, which is surveillance, and reactive monitoring, which is more of an alerting system. So I want to be proactive. I want to keep an eye on things, but I also want to react, and I want to be able to respond when things happen. And a couple of the systems that we're going to talk about, or the 3 main ones, and maybe a 4th that's part of one of the other 3. Anyway, there's Cloudwatch, and its number of pieces inside it. So Cloudwatch Logs, Cloudwatch Events, or Event Bridge now, and all the little pieces inside it. And then Cloudtrail, and then, which we'll talk to in a little bit as far as doing root cause analysis, AWS X-Ray. So Cloudwatch and Cloudtrail are similar. They do similar types of things, but they're different. And you need to know when you would use them to monitor your system and manage your system's performance, or I don't mean performance as in like highly performant, but just what's happening. So Cloudwatch is really looking at the services themselves. So Cloudwatch Logs, I can look at the performance of the architecture. So I use Cloudwatch to look at metrics on an EC2 instance. So this is how something is happening. Cloudtrail is much more of not much more, it's the API calls that are made inside AWS. So what makes these things different? So if I look at it from an EC2 instance, I could use Cloudwatch and Cloudwatch Logs to monitor my EC2 instance to see how it's performing. I could see what's happening to my infrastructure. But I would use Cloudtrail to see what the application is doing. So if I make an API call to another service or to another feature, then Cloudwatch won't see that. Cloudwatch is just humming along. Look, you're still running. That's great. But Cloudtrail is going to say, oh, here's who I'm talking to. I need something from S3. Cloudwatch won't catch that. Cloudtrail will. Or I need to decrypt this. And so, oh, I'm going to go talk to KMS. Because it's an API call, it can be caught. You create a trail and you tell it, excuse me, what you want. And inside the trail, I can now see everything that's happened with my environment. And now, again, this is about code. These are the API calls. There are other services and features available that can do some monitoring, but these are the 2 big ones that I saw in the exam. You could look at AWS config, and you could look at some of the tools around that, or even Trusted Advisor to an extent, to see what's happening from a security perspective. But those, as far as monitoring code, are not nearly the bread and butter services that these two are. And then, so this, we're kind of bounce back and forth between the two subdomains, but performing root cause analysis. So here I have inside Cloudwatch, I get a message that provision throughput exceeded message. And this is one, excuse me, that when I see it, I know something's happening, but I need to figure out where it's happening and what does it mean. Now, where would I look for this? And this is something that I would see inside Cloudwatch, because this is an error message that comes back from the service. This is not me necessarily talking to my service trying to make a change. This is something that's come back. And I specifically wanted to pull this one out because I've seen this particular error message in multiple AWS exams. I've seen it in the developer exam, and I've seen it in, I can't remember now if it's data analytics or the machine learning. I'm pretty sure it was data analytics, where I need to know what to do with this and what does it mean. And from a developer perspective, I don't necessarily need to know like what all of the different things I've done to cause Kinesis data streams to return the message. I need to know what it means in terms of how do I fix it? What do I have to redo? So this means that I need more throughput, and to get more throughput inside Amazon Kinesis data streams, I need to increase the number of shards that are available. Shards are a measure of capacity, and they're basically an amount of, the more I have, the better throughput I have, the more performance I have. But I also need to know to implement some sort of exponential backoff on using get records and put records. Now, these are probably as close as you're going to get inside the exams as far as some of the technical programming things, because these are two APIs. But really, what it's asking you to know without telling you this, and this is kind of infuriating if you've never seen it, because it's not really explicitly stated anywhere. But once you've used AWS and you've coded inside AWS and you've deployed your code in AWS, you're gonna be like, oh, that makes total sense to me. Is that things like to implement exponential backoff and get records and put records, those are intrinsically part of the SDKs that AWS makes available. That concept exists inside the SDK, and if you know that it's there, then you just say, oh, it'll do it for me, and I don't have to think about it. But if you decide to manually do things, if you do things by hand, then you need to know how to do that, and that's just an awareness. So really, to me, this is an understanding of, as much as it is of Kinesis data streams and what provisioning and the throughput is available, but it's understanding that the tools that are available in the SDKs are that they have a measurable value. The other thing, as far as monitoring and troubleshooting, the second part of the subdomain, 5.2, perform root cause analysis on faults found in testing or production. To me, besides looking at some of the stuff that shows up in Cloudwatch Logs, or Amazon Cloudwatch, Cloudwatch Logs, and Cloudtrail, is AWS X-Ray. Now, AWS X-Ray is an interesting thing. I am relatively new to using it and didn't spend a ton of time on it. But I am glad that I basically took the time to understand how it's implemented and what it does. And you need to understand from when taking the exam that it is available to monitor your code. It can be deployed on EC2 inside containers with ECS, the Elastic Container System, AWS Lambda, and Elastic Beanstalk. There are a number of questions about Beanstalk on the exam in general, because it is designed for programmers to basically build infrastructure without having a solutions architect or a sysops person available. You basically deploy in the code and you update your code and you push it out as needed. But X-Ray was designed and implemented to help monitor distributed code, and that is an important thing. But before I go too much farther, not in this particular presentation, because I only had so many slides to work with, but be aware not only of what X-Ray can do, but how you implement it, because it is possible to implement it not just in the code itself, but to run it on premises to monitor solutions as well. So when it runs on EC2, there's a daemon that's available, and you need to know how to configure that daemon. And if you can configure it in the privacy of an EC2 instance, you can also do something similar on premises, and you should be aware of that. Not necessarily all of the reasons why, but how would you implement it so that you could track your code? Because sometimes code starts in an on-premises data center. It starts at home and then moves into the cloud. And so you need to be able to track that. So I'm going to come back to the X-Ray when I talk about some questions, but remember, just keep in mind that kind of the key concept for X-Ray is that you're monitoring distributed systems, distributed code. So common services for monitoring troubleshooting, these are the three big ones: Amazon Cloudwatch, Amazon Cloudtrail, and AWS X-Ray. These are the three that I remember seeing most recently. There probably could be other services that are called and other services that are used, but by and large, these are the most important ones. Exam type questions. So here, number 5, domain 5. You've created a Lambda function for a web application, web backend, and when testing the function from AWS Lambda, you see it runs, but Cloudwatch is not logging data. You wait several minutes, you start to troubleshoot. Why are the logs not appearing? Now, here's one of those things that you need to know how the services are implemented. And this is one of those that the service, the question itself could really be much more, much simpler than you expect, because it depends on what you have available. But for me, if things are not appearing, then I've configured it wrong. Like I've done something wrong with configuration. Now I know something about logs, and that is if you create a filter, that log filter won't go back and retroactively look at the stuff that has already come. So maybe the filter is the problem. But usually if I have something new that's not showing up, then I have a problem with permissions. So you need to know how to give permissions to the Lambda function to be able to write to Cloudwatch. And this is done through IAM and specifically using a role. And this is really about your understanding, less about the understanding of Cloudwatch and more about the understanding of how permissions work inside AWS. The default permission for any service inside AWS is no, it is deny. You actually have to be explicit in everything, which is both good and bad. It's kind of a dual-edged sword. So it means you have to manage it, which means work, but at the same time, it's on you to allow access to your services and functions. So here's another type of question. You've deployed 8 applications running on multiple Amazon EC2 instances. Your operations team has asked for a graphical display with one key performance metric for each application. What's needed inside Cloudwatch to make this happen? And here I give you a choice. It could be either a custom dimension with a unique metric name or a custom namespace with a unique metric name. And the idea here is that what I want to share with you is that you may see some of these tricks of language, these tricks of phrase, where they give you 2 similar answers, and you know that it's going to be, and there may be 2 other things that are listed, like, you need a raft with a sailboat, or you need a sailboat with a motor. Like, those things are ridiculous. That's not right. That's not even a thing. So get rid of those. Then you have the 2 left: a custom dimension with a unique metric name or a custom namespace with a unique metric name. And what we're testing here is not necessarily, do you know how to do it, but have you done it? Do you know what it means? And so, do you know what a dimension is? Is there such a thing? And there is, right? There is such a thing. So now it's testing you, there's a thing, but is there a namespace too? Oh, there is, but which one do you use? And you need to understand that a dimension is it's a way of like kind of isolating or putting a tag on a metric, and a namespace is a collection of metrics that I want to monitor, a collection of things I want to monitor. And so in this case, what you need is a custom namespace with a unique metric name. So again, this is not the theory of Cloudwatch and Cloudwatch Logs, and it's, have you done it? Have you done the work? And what does it mean? You have a manager. That is a requirement that AWS Lambda Functions log errors to Cloudwatch so that system administrators effectively troubleshoot issues. What is this testing here? It says, what should you do in order to ensure this happens? What is this testing? It's testing your understanding of logging. Would it be in Cloudtrail or will it be in Amazon Cloudwatch? And if the requirement says that I want system administrators to be able to troubleshoot things, system administrators are not programmers usually. I mean, sometimes they are, not coders. They're looking at logs. They know how to do infrastructure. So they need Cloudwatch. They need access to Cloudwatch. And this is a point where the Lambda function needs to be able to write to Amazon Cloudwatch to help the system administrators. If you were troubleshooting an application, that would be something different. That would be an AWS X-Ray or Cloudtrail. And so you need to know that Lambda logs all requests, and you can insert logging statements. So if you're a Python programmer and you know logging.log, I can put those logging statements into my code that will show up in Amazon Cloudwatch. I can also set it up so that they show up in Cloudtrail. And it depends on what you need to do. So who's your audience? What is it you're trying to do? And so this particular part of the documentation, I just kind of outlined what it looks like. So Cloudwatch would be your answer on this particular case. You need to analyze performance issues with applications, distributed applications, multiple API calls to external resources. This is screaming to me, and it should be screaming to you, the word distributed, right? I have distributed, and distributed tracking is a challenge, right? It's the challenge of the 21st century, I guess. Back in the 80s, we had like client servers and still some mainframe things, and moved more towards client servers like directly in the 90s and tracking those kinds of applications. Distributed applications that are run on demand, all those things, that's like the thing that we're trying to fix. And that's an AWS X-Ray question. So this is from the kind of the marketing slick main page of the AWS website. And AWS X-Ray helps developers analyze and debug production distributed applications, and blah, 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 blah. And then you see the word performance. So the idea is that I can use X-Ray to create traces to trace my application as it moves through AWS, in and out and around, to figure out what's going on. And you don't necessarily need to know how to implement it. You don't need to know how to code it in such a way to get these things. What you need to know is, what does it get you? What is the benefit? And what you need to do to enable it inside your environment. Those are the key things, key aspects. So again, important services for both domains, from domain 4, for refactoring microservices, Lambda functions, AWS Lambda, no AWS or Amazon S3, Sqs and Sns, Amazon Cognito, single sign-on, and not necessarily in depth, right? These are not, when would you use them? Why would you use them? And they're trying to get you to avoid hard coding or building things from scratch that are already available to you. Because if you use the internal services, if you use the existing services rather, you can enable some other monitoring and logging services. With domain 5, Amazon CloudWatch, Amazon Cloudtrail, AWS X-Ray, Lambda functions. And really, I put Lambda back in there just so that you know that you need to figure out, when you create a Lambda function, what is it that you're doing as far as monitoring? Is this a CloudWatch monitoring issue? Because that would be even EC2 or anything else that has a hardware-like component. It doesn't have to be hardware, but it has to be a component that has it underneath it. Or is this a software thing where I'm making an API call, in which case that would be Cloudtrail. If you have a hard time sleeping, I highly recommend some white papers. okay, you should actually go through some of these white papers before you take the exam. Don't have to memorize them, though sometimes it seems like they basically copy the text from this to build some questions, some of these white papers. Implementing microservices on AWS, if you've only ever built like monolithic applications, you should take a look at what it means to implement microservices on AWS. Serverless architectures, they're still a server, right? We don't make them go away. We just don't make individual people manage them anymore. But how do you trigger them? How do you run them? What does it mean? How long can they be? How do I run them synchronously? Step functions. How does it matter if they're asynchronous? How do I integrate those with other AWS Amazon functions? It's always good to read the well-architected framework, because this really gives you an idea of what it means to build an application in the cloud. I have more than once said that the cloud is very much like my dad. When I was growing up, it was turn out the lights when you leave a room. I'm not paying to light up a room that nobody's using, and close the door. I'm not heating the whole neighborhood. If you've heard those words come out of your parents' mouths, then that's cloud computing. If you're not using a resource, turn it off. If it's insecure, you don't want to let the entire neighborhood see your stuff, right? Close the door, lock the door, protect your stuff. And if you're not using it, turn it off. And then finally, I don't have a link for it because it's a little bit on the older side. If you haven't read the Dynamo white paper, this was one of Werner Vogel's first published papers working for Amazon. And it outlines kind of distributed databases, which ends up becoming the Dynamodb service, and describes that in detail. It is skip through some of the math because it's in there and it's like, oh, I can't, my brain. But if you read the rest of it, just like the concepts behind it, it explains so much as to why AWS is and distributed computing is the way it is, and the problems it solves, as well as some of the problems it creates that you have to pay attention to. With that, concludes kind of my overall discussion for today. I would like to know if anybody has any questions. And it will take me a minute to check that document. From the audience, can you use an external monitor for a big screen while taking the test? You know, I've only ever used my laptop with taking the test. I would have to confirm. You can reach out to Pearson VUE. I'm pretty sure the answer would be yes, because they don't really care what computing environment you have. It's important that there's no way for you to cheat. So they would probably ask you to take pictures of it, what's around it. There's no extra inputs on it. I will tell you that when I took the beta SysOps exam, at the same time I took the developer exam. I took 2 exams in a day. I do not recommend it. It was exhausting. My head hurt. There's a lab environment. It's now part of the SysOps exam, and I'm going to bet that eventually the developer exam will follow suit. But it was small, right? It was on my 15-inch, 16-inch laptop screen. It was still kind of like squeezed in there, and so I had to get my face really close. And the proctors, 2 proctors came up or popped up on my screen saying, "Your entire face must be on the camera at all times," because I got my face so close so I could see the display. So I think that would fix the problem. So I would say that it probably is the answer. I don't work for Pearson VUE and I don't speak for them, but as long as you can prove that you're not trying to cheat, you'd be okay. The difference between X-Ray and Kinesis, those are 2 radically different things. And so AWS X-Ray is you're putting traces into your code that you can follow as they move through your environment. So say you have a Lambda function that calls another Lambda function that reaches out to another service like S3 or KMS or whatever, and you want to see what happens. So I can create kind of a workflow, and I can see visually where things are happening. Kinesis is streaming data. So I want to actually move data from one place to another. Kinesis video streams is for binary data. It's just called video streams because they used video with it first. Kinesis streams, data streams, Kinesis firehose, Kinesis data streams, Kinesis data firehose. Those move data at real time or near real time from one place to another, depending on your use case. Kinesis Data Analytics is a service that can actually analyze or provide analytics information, statistical information, and similar information about the data while it's moving. Cloudtrail and X-Ray. So Cloudtrail, what is the difference between Cloudtrail and X-Ray? So if I use Amazon Cloudtrail, I can use it anytime an API call is made into my environment from any system, any service. So if I want to see, if I have a trigger that triggers an event that I haven't done. So say I create a trigger in S3, I put an object in S3 that triggers a Lambda function that sends some data to RDS and sends something, I don't even know where, sends something to RDS, sends something to into Kinesis, right? So whatever it is, I can use Cloudtrail to watch what's happening, and in almost not necessarily real time, but I can see the actual events display, like unfold. With X-Ray, I'm putting things into my code, like not logging statements per se, but I'm putting information, I'm putting a system in place that I can move as data moves. If I want to follow this thing, it's like taking a picture of your, like an X-ray of your body. I want to get a picture of what's happening where. I did say X-ray could be used on premises, and that's one of the questions. It has some specific needs. So you have to run the daemon and you have to give it certain permissions, and you use, and I don't necessarily want to walk you through all of that, but you can look it up in the documentation, but it involves not really a role, but if you've ever configured the CLI, it's very similar, excuse me, to how the CLI gets configured on a local machine. What is your input advice on the Solutions Architect Associate? Any changes or updates in format? So that is out of the scope of this particular webinar. However, I will say that my impressions of the exams, the associate level exams, are threefold. There are three things. So the architecting exam is really designed around how do you build it, right? How do you build the infrastructure? What does that look like? The developer exam are some of the how do you do the deployments? How do you manage deployments inside AWS? And then the SysOps exam is really about implementation details and how do you monitor it and take care of it, the care and feeding. If you were to talk about difficulty levels of the exams, and your mileage may vary, this was for me, and this is my impression. I do not speak for AWS. I do not speak for Cloud Academy in this regard. I can only speak to myself. And for myself, I will tell you that I believed that the AWS architecting exam was the middle of the road exam, was that SysOps was the hardest of the three, and that developing and developer was by a slim margin the easier, because I think it's more focused on a set of tasks. And that's my opinion, and it's mine alone. Are there questions related to code commit, code build, code deploy, and code pipeline in the exam? Yes. Next question. So if you're asking me a question, you should probably ask an open-ended one. Yes and no. Those services are not necessarily called out by themselves. I did not see them on my exams. I did not see a specific thing on the developer exam about code commit, code build, code deploy, and code pipeline. Pipeline I saw on the SysOps exam, or some references to that. What you will see is the idea about deployments in maybe more so like in Elastic Beanstalk, where you have blue-green deployments or red-black deployments, and how do you manage those? Usually those you won't see things like how do I commit to a repo and how do I do a pull request? Those questions do not. I did not see any. There was one that alluded to something like that, but it wasn't necessarily like how do you do it? It was much more of a, well, I need to make sure that this code doesn't get deployed accidentally. What do I have to do? and it's about approvals. Related to the question about like trace ID, so Amazon X-Ray it's its own thing, and I have a hard time comparing it to other things, but if you could kind of think of it like creating, I guess trace ID. Yes and no, it's different. If you just look at some of the documentation and some of our some of the kind of the frequently asked questions behind it, you'll see that really it's just about following data. So rather than say, well, what's happening, and you try to find the thing that you want, right? You're trying to find a thing, and you don't really know what's going on. Using X-Ray lets you create a trace. So you can trace a specific thing, a part of your code, a part of the interactions with your code as it moves from microservice to microservice, because it's designed to be distributed. And I mean, it's overly simplified, and because I only have like a few more minutes left, I can't really go into the great detail because I need a whiteboard and some documentation. But it's really designed to allow you to find the problems in an application that is distributed, as opposed to something that's monolithic. Are there questions related to snowballing the exam? No. Unequivocally, no. I was kind of thinking that I might see something with outposts, with some of the kind of like, how do I manage this stuff remotely? But I did not see anything like that. It was all about. I kind of think of it now, kind of thinking about it out loud, is that the developer exam really isn't about developing on AWS. It's about supporting the care and feeding of developers and developer environments. That said, I did not see any code commit, code build, code deploy, Cloud9, none of that stuff showed up. No specific questions about SDKs, like how do you do this in Java? How do you do this in Python? How do you do this in C#? None of that. The questions were like, oh, I built this thing in Java, or I built this thing in Python, I've built this thing in Golang. Now, how do I secure it? And that's usually about roles or using KMS for encryption and the like. What is your opinion on the questions related to AWS database services? How difficult are the questions? That's an interesting question. And it's interesting because my perception of some of the database questions is that there aren't a lot of them outside of the generic, I have an endpoint. Because it seems like, because they've created the database specialty exam, the specialty certification, that most of those types of questions have been moved over, and they expect you, if you want to be a database specialist, they're going to be over there. That said, there will still be questions. You might see questions about, well, how would I improve performance, or what's this performance thing when it comes to databases? And a lot of times that's involving caching, which would be a refactoring question almost. It involves caching with even Elasticache or Memcached, or some sort of read replica and the like. We have about 10 minutes left before I believe my session ends on this particular thing, on this particular webinar. So I am going to have to wrap it up shortly. Does anybody else have a last minute question for me? With that, just one last quick check about the questions coming in through the chat. I would like to say thank you. There will be a survey that follows. Please complete it. Let us know what works for you, what doesn't work for you. I read the comments, I read all of them. Sometimes I'm amazed, like, did you really come here for learning about this particular topic? But still, I will read them. If you need us to, I will try to respond. And this gives us insight and information about where to go in the future, and what webinars to provide, and what details you were looking for that we didn't. So thank you very much, and have a splendid day.